Hello everyone. Today let's solve the problem number 131, palindrome partitioning. So what the question states here, we are given a string s. You can clearly see we are given a string s and we need to partition it into substrings. So what we need to do here, we need to partition this string into a substring such that what is the condition? Such that each substring is a palindrome. So each substring should be palindrome. They have given here the definition of substring and palindrome. Substring states that a substring is a contiguous non-empty sequence of characters within a string. Just keep this in mind. So what is a palindrome then? Palindrome is a string that reads same forward and backward. This we have to keep in mind. If we have AA, so this is a palindrome. Suppose if we have AA, so it reads forward and backward same, right? So this is one of the example for the palindrome, right? So what we need to determine here, we need to partition each into substring such that each substring is a palindrome. We must return all possible palindrome partitions of yes. What we need to return here, we need to return all the possible palindrome partitions of yes. So that's what we need to return here. Output that we got here as A, B. So these are all the palindromes for the individual this thing characters, right? And this is for AA and finally B, right? So these are all the palindromes. So that's what we need to do. We need to return all the possible palindrome partitions of yes. So this for this example, they have given the output this one. Same goes with the output 2 as well. We have only single character, so output will be A. Right? I hope the question is completely clear. So as usual, first let's discuss the approach followed by edge cases and then finally write the code and discuss the complexities of the code that we have written. Initially, let's discuss the approach. So here, the approach that we'll be going with here is backtracking. Just keep this in mind. I have considered the example 1 that they have given in the first example that they have mentioned in the question, right? So the approach that we'll be going with here is backtracking. Let's consider the example and see the step-by-step execution, right? So first what we'll be doing in the first step, we will be starting at index 0 and try forming the substring. At index 0, we have A. According to the example, we have A, right? So A, we'll just consider A. A is a palindrome, right? So A is a palindrome. So we will continue. Why? Because A is a palindrome at the first index. Now let's move on to the second index, right? We will start at index 1 now or next index and try forming the substring. We have A. Again, A is a palindrome. So we will continue. So A is a palindrome here. I'll just mention this one. A is a palindrome again. So let's move on with the third step. So I'll just come here. Let's move on with the third step here. Here in the third step, what we will do? We will move to the next index or the second index or the final index. So this we will be considering B. B is a palindrome. Just B is a palindrome, right? So here B is a palindrome. So what we will do? We have reached the end. So as we have reached the end, we will be storing this one. No, now B is also palindrome, right? So what are all the palindromes that we got here? A, B, and A and B. So I'll do one thing here. Let me erase this one. So yeah, it was A and B. So this is the palindrome that we got here. So we are storing the same thing as we have reached the end. So now what we will do? We will backtrack. Now means when I say we will backtrack, we will remove the last B. Now we have saved A and B. So what we will do in this step? We will remove B and we will try another option. Already we have A. So we will ignore this one. Already we have A, right? So we will try this one, AA within the first index now. This will be the fourth step. So we will try AA in the first index. This is palindrome. AA is palindrome, right? So now we will try AA at the index 0 instead of A. Now AA is palindrome. So what we will do? We will continue. This is palindrome. A. This is palindrome. We will continue and we will move on to the fifth step. Now we will start at index 2. So instead of single A, we will continue with we got double A now as palindrome. We will start with index 2, nothing but this one, B, right? So now what we will do, B is also a palindrome. So we will start with B and this one is a palindrome. So B is a palindrome here, right? This is fine. We have reached the end now. What we will do, we will store this one AA as well as B here. I hope this is clear. So final result would be what, this one and this one. We are storing this one and this one, right? So final result will be this one. What is the final result that we got here? A, this one A, B, and another one is AA and B. So this is the approach that we will go with, right? So we have made use of the backtracking here, right? Initially what we did, we started at the index 0 and try forming the substring. So in that case we got AAB and we stored this one, right? Initially, as we had reached the end here, we stored AA and B and then we tried with the backtrack. So we tried forming with double A instead of the single A at index 0. As we are making use of the backtrack, we removed B and we tried with double A. So we got AA as a palindrome and finally B. This forms another this one, palindromic substring of palindromes. Palindromic substring. So this is fine. Final result that we got here is this one. So this is the approach that we are going with. Now let's discuss all the edge cases and then finally write the code. So the first edge case I want to discuss here is this one, a single character input. Let me give here single character input. So for the single character input I'll just consider A here. This is the input. Output will be here in this case A itself, because we have single character, right? So output will be A itself. So why? Because a single character itself is a palindrome. So this is for the first edge case. Let's move on with the second edge case, string with all the identical characters. This is for the condition, string with all the identical characters, right? So let me move on to the next page. This one, I'll just consider the input. We should have all the identical characters, right? So input I'll consider here same thing. Similar to the first example they have given in the question. So instead of B, I'll consider all the identical characters triple A. So the output will be here in this case A, this one A. This forms one thing. You can try this one in the similar way that I showed for the example one. So you will get the same output, similar output, not the same output, sorry, similar output. So this is this thing, palindromic substring. This forms another palindromic substring. Finally, this one. This is fine. Why here? Because every substring is a palindrome. We know that every substring is a palindrome when string with all identical characters are present. So this is for the condition, string with all the identical characters. So let's move on with the third edge case. When I say third edge case, third or the final edge case, this is for the condition, string with no palindromic partitions. String with no palindromic partitions. This is fine. This is the final edge case. So input I'll be considering here A, B, C. This is fine. Output will be here in this case A, this one, B, finally see here. So why here we got distinct characters in each array as output? Because only single characters are palindrome in this case. Every character is different, right? So only single characters are palindrome in this case. This is for the condition string with no palindromic partitions. So these are the edge cases that we need to keep in mind. First edge case we discussed is single character input. Second one was for the string with all the identical characters, and third one was for this one, string with no palindromic partitions. I hope all the edge cases are clear. Next, let's start writing the code. Initially what I'll do, I'll just consider here result variable to store the result, and also length, right? The length of the is this one, string. So that I'm considering. This is fine. The next step is, I'll do one thing. I'll just write this one in the same line instead. This is fine. So next step is, I'll just make use of the function to check if a string is palindrome or not. Simple function, is palindrome I'll consider, or is this one is fine. Let me pass the string as parameter here. String, let me give here split and reverse, finally join it as a part. So this is fine, joining all the letters finally. So we are just checking we are just writing a function to check if a string is a palindrome or not. This is a simple function, right? So now let's consider the backtracking function, or now let's write the backtracking function to find the palindrome partitions. We need different partitions here. You can clearly see we discussed that one in the form of example, this example itself, right? So we need a palindromic partition. So let's write the backtracking function to find palindrome partitions. So I'll just give you a const backtrack. Let me pass the parameters I and path. So here within this a backtrack function, so the first step is, if we reach the end of the string, then we will store the valid partition. So we saw that one in the example. If we reach the end of the string, end of the string, then we have to store that one as the valid partition, right? So I'll just write a single simple if condition here, I equals n. If we have reached the end of the string, then what we have to do, we have to store. So we have considered result variable, right? So I'll just give here result dot push. So this case is almost same for all the backtracking problems. So if you observe, right, even when we solve the combination problems, subset problems, different permutations, so this most of the steps are common, right? Most of the things are common when we are solving the backtracking problems. So within the array, I'll just consider the path here. Let me consider the spread operator. Let me give path here. Did I miss something here? Just give me a second. Why? So one parenthesis is enough actually. This is fine. Next, let's iterate through all the possible substring. So I'll just give here, let j equals 1. So sorry, we have to move to the next number, right? We have to iterate through all the possible substrings. So here this will be I plus 1, j less than or equal to n. Let's increment the j as well. So this is fine. Let's extract the substring that we got. So I'll just consider sub as the variable name. Let me give here s dot substring. We have to extract the substring that we got. So I'll just make use of this one built-in function s dot substring of from I to j. We are just extracting the substring, right? So in this case, so now let's check if it's a palindrome and then choose the substring, right? So to check if it's a palindrome, we have already written is palindrome function, this one, right? It's palindrome. I should have copied the same thing. This is fine. Of substring, this one, if it's a palindrome. This one we are considering. We are checking if it's a palindrome. Next step is we have to choose the substring. We have the path as parameter, and we'll make use of push. What we will push? Substring, right? I hope this is clear. Next step is we have to explore further as well, right? Then we have to backtrack to explore the other partitions as well. We saw this one in the form of example. So we have to explore for all the string and all the partitions. We have to backtrack to explore other partitions as well. So for that one, I'll just make use of the backtrack here. Recursive function. So J path. We are just exploring further here. Finally, we need to backtrack to explore other partitions as well. One partition is finished. So in the example also we stored that one, we stored the result, and we tried to explore other partitions as well. In this case, this one got finished, and we tried to explore this one, right? This partition, we have another partition, so we have to explore other partitions as well by making use of the backtrack. So here I'll just give path.pop. In this case, if you remember, we removed B and we tried exploring double A instead of single A at index 0. That's how we got double A here. In the next partition, double A, and next finally we went to index 2 and we checked for B. So double A and B, we got this one as palindrome in this partition, if you remember in the example that I showed, right? So that's what we are doing here. We have to remove the B. So path.pop I have given here. That is the reason. So I hope this is clear. So next step, I'll just come out of this function, backtrack function entirely. So we have to start the backtracking from index 0. We need to start the backtracking from index 0 in this step. So here double A we started from, right? We are always starting the backtracking from index 0. So that is the reason I'll just keep here backtrack 0 and empty array. So initially, we are starting backtracking from the index 0. Finally, we have to return the final result, right? We have to return the result, nothing but, we have made use of the result variable. You can clearly see. So I'll just return a result here, res. So this is it. Let me format the code once and let me hit the run button. So we are getting the wrong answer. Let's check what. So in line number 4, what I have done here is I have considered first parameter as a string. I have to consider str again here, right? So str equals to this one I have to check. So this one I forgot actually. Let me format this one again and let me hit the run button. So here now you can clearly see all the sample test cases are getting passed here. So let me hit the submit button now. So you can clearly see here all the test cases are getting passed here. So the code works absolutely correct in this case. So let's quickly discuss the complexities of the code that we had written. So the approach that we went with here is backtracking. We know that recursive backtracking or backtracking. So overall time complexity would be here 2 to the power of n, big O of 2 to the power of n. Why here the time complexity here is big O of 2 to the power of n? Because each character can either be included in a partition or merged into a previous partition. We saw that one, right? In the form of example when we considered the example walkthrough, right? So since each character can either be included in a partition or merged into a previous partition, we have exponential number of partitions. So overall time complexity would be big O of 2 to the power of n in this case. So what will be the space complexity? Overall space complexity here would be big O of n. Why here space complexity is big O of n? Because we are making use of the recursion stack. So the depth of recursion is at most n. We know. Why? Because when every character, it's n, because when every character forms its own palindrome partition, it will reach to n, right? So the depth of recursion is at most n. So overall space complexity would be big O of n here in this case. So overall time complexity would be big O of 2 to the power of n, and overall space complexity would be big O of n. I hope this is clear. I hope the solution we wrote is completely clear. For now, this is it. Thanks for watching, guys.